And there I am. Okay. So, yeah, I've got some things to share with you. First of all, good evening. Hope everyone's feeling well and getting through and enjoying the summer, enjoying the weather, whatever. So, first thing I want to do is start to share my screen. You should all be seeing my calendar. And I'm also going to do this. Let me stop sharing for a second here. I want to stop my video. All right. I'm going to go back. Thank you. I don't know how that happened. Who said that?
Tiffany.
Thank you. I don't know how that happened, Tip. I don't know how that happened, but I'm glad you saw it. Thank you. I don't know how that happened. All right. Number 9, you get this frequency distribution, and he says here, construct a corresponding relative frequency. Relative. Well, relative means it's some sort of a decimal, which which could be changed into a percentage. Here is the key. When you're presented with a problem that wants relative frequency, to find a relative frequency, you need to know the total frequencies. In many of these problems, and many problems in mathematics, especially in statistics, they give you the information, but it's sometimes not, it's not like thrown in your face. It's not obvious. Here's a case for me to find the relative frequency, the decimal or the percentage. I have to know the total relative frequency to get a percentage. Well, he doesn't tell me the total. Well, how hard is it for me to take 60 on my calculator, add 73, add 91, add 89, and add 15? My total is 328. I'm looking for the first class here between 200 and 300. The frequency was 60. I take 60, I divide it by the total, which I added up on my own, 328, and I come up with a decimal, 0.1829. Well, 0.1829 as a percentage is 18.29%. You know very well from grammar school to take a decimal to change it to a percentage, you move the point 2 places to the right. Look at letter A for this first class, 12.5. Well, that's not 0.1829. 15.5 is sure not 0.1829. In fact, 15.5 would be 0.155. This would be 0.125. Look at this crazy answer, 27.33%. Well, that's not 0.1829. Oh, look, letter D, 0.8129 expressed as a percentage is 18.29%. But what I'm telling you is, if you have a problem like this, which you will, the total will not be given to you. You've got to add the frequencies up on your own because you're big boys and big girls, and then take, once I found that this answer was right, there's no need of me taking 73 and dividing it by 328 to prove to myself that it was 22.26%. This is the only one that had the right first answer. That is it. You are done. Move on. Here's another case where, this problem here would take you literally, about a minute to do. Key thing is, with a relative frequency, you need to know the total, and the total is never given to you. You have to add up the frequencies on your own. Another dot plot. You're not going to have 2 of these. You may see, I think you'll see 1, minimum of 1. As I look at these here, I always look at the answers when these dot plots, and I try to find the discrepancy. And what I notice here with letter A, this is 10, then this number represents 11. There's 1 dot over 11. This guy, letter C, has 1 dot over 11. Letter D has 1 dot over 11. Letter B doesn't have any dots over 11. So I say to myself, let's see. Oh, here's my data here. Guess what? There are no 11s. So it can't be a dot over 11 if there's no 11s in my data set. Oh, letter B doesn't have any 11, so it's correct. I'm done. I got my right answer. There's no need to be figuring out, hey, are there 2 dots over 12? Yeah, I guess what? There's a 12 there, there's a 12 there. But once I found out that there were no 11s and letter B was the only one that didn't have a dot over 11, what more could I do? I got the right answer. Move on. Move on. Don't be sitting there and second guessing yourself. Oh my gosh, same idea, except the data is given to you as a distribution. So I look at I'm scanning them, and it's 1 dot over 0, letter B 1 dot over 0, letter C 1 dot. Okay, so they all have 1 dot over 0. What else do I see? The discrepancies. Oh, look at this over here. There's no dot over. That's 0. This must be 1. This must be 2. There are no dots over 2. This guy, letter B, has 2 dots over the 2. This letter A has 1 dot over the 2, and letter C has 1 dot. Let me look at my data. Well, guess what? What's the frequencies of 2? There are 0 2s. Well, 0 2s means there's no dot over the 2. It's got to be letter D. There's ways that you can, not everybody attacks the problem the same way, all right? Not everybody has the same test taking scheme or way of doing things, whatever. I mean, we all look at things a little different, but I'm trying to give you some hints here, how you don't have to spend a lot of time on this and just kind of move on. Trust what you're doing. All right. Trust what you're doing. All right. These stem plots here again, this is just a way of expressing data of different ways. You have pie charts and bar graphs, and then in some industries, maybe a stem plot is appropriate, whatever business it is. Our job here is just to look at different ways of expressing data from some sort of a data set. Here again, I look for discrepancies. This is the tens place, the stem, and these are the ones. So 3 and the 0 stands for 30. A 3 and the 2 stands for 32. Well, letter A and B both start out with a 0 and 2. So there's a 30 and a 32. There's a 30, and then I see the 32. Now watch the discrepancy here. Letter A has only 1 3, which is telling me there's 143. Letter B has 2 3s, so it's telling me there's a 43 there, there's another 43 there. So I look at my data. How many 43s do I see? Well, I see 1 here, and I see another one there. So letter B is right. There are 2 43s. The minute I saw that was a discrepancy, I just checked my data. Do I have one 43 or do I have 2 43s? Well, yeah, I got a 43 there and a 43 there, so it's letter B. What more can I do? Move on. Letter A and letter B, what's the discrepancy? This is 21, which stands for 200, and well, the 2 1 in the 5 stands for 215. The 2 1 in the 7 is 217. 2 1 in the 9 stands for 219. Well, the discrepancy is letter A has a number 217. 21 in the 7 stands for 217. This guy doesn't have a 7. So I'm saying to myself, do I have a 217? Well, I don't. I don't have any number that says 207. 17, so it can't be letter A because letter A has a 7. The 21 and the 7 means 217. But guess what? There is no number 217. So letter B is correct. There's nothing more I got to do. I don't have to check that 221 is there or 239 is there. Once I found that letter B didn't have that 217, I was done. Mark it and move on. Why keep checking it? For what? Not going to change. Same thing here. I'm looking for discrepancies. What do I see? I see a 2 3, a 2 3, a 4 4. Oh, all right. This guy here has a 2 and an 8, which stands for a 28. The 2 and the 8. This guy does not have an 8. Well, look at your data. Well, wait a minute. There is a 28. There's one of them, right? 28. The 2 and the 8 stands for 28. This guy didn't have an 8. He is wrong. There is a 28, and I see it right there. So that to me is the best way to approach these stem plots. You only have one of them. Look for the discrepancy and figure out which one is actually telling you the truth. All right, pie charts. Once again, to come up with a percentage and a decimal, you still need to know the total. Well, luckily enough, he told me the total was 44,000. All right, that was a sum of the capes, the garrisons added with the split level homes. What percentage of those were capes? Well, 11,000 over 44,000. I'm changing this into a fraction. The lowest terms, it's 1/4. 1/4 is 0.25, which is 25%. Well, letter B has the capes down as 30%. Well, 0.25 is not 30%. Oh, look at letter A, 25%. Once I figured out that letter A had the right one, the right percentage for capes, there's no need of me to figure out the percentage of garrisons and splits. It can only be letter A. It can't be anything else. There's no need to check in anything. Just keep on, just move on. Once you find that the letter A was right with 25%, what are you doing? Move on. Here's the case here. I added them all up. I don't know why. He told me that there were 70,000 acres. My discrepancy here, I'm looking at forest. I just picked forest. I could have picked farms. I could have picked urban. Forest, according to this pie chart, represents 15% of the total. Well, he told me that in the problem, forest was 10,500 acres divided by the total here again, 70,000. Your calculator will do this, change it into a decimal. 0.15 is 15%. 0.15 is not, according to this circle graph, 20%. No, 0.15 is 15%. There it is. There's my discrepancy. I know it's letter A, can't be letter B. I don't need to do anything else. This is a crazy one. He says, hey, we surveyed 9,833 vehicles on the campus of State University. It yielded the following pie chart. What percent of vehicles were hatchbacks? Huh? Well, hatchbacks, 36%. 36%. I don't apologize, but there it is. I mean, I thought the other ones were easy. I guess nothing gets gets as easy as that. I mean, there it is, hatchbacks, 36%. Of course, you got to be able to read too, which is helpful. You got to be able to read. A survey of 3,367 vehicles on campus, Oregon State University, yielded this pie chart. And the question he's asking me, he says, find the number of vans. Well, vans represented 8%. 8% of what? The total of 3,367. All right, 8% as a decimal is 0.08. You multiply 3,367 by 0.08. Don't multiply it by 8 because 8% is not 8. 8 is 800. 8% is 0.08. I don't believe I'm saying this, but I am. 0.08 times that number on your calculator is 269. It's rounded to the nearest whole number. Now, because of the 4, a 3, a 2, a 1, or a 0, you round down. In this case here, you round it down to 269. Find 8%. What's the total inventory? Well, this will take you a few moments, but you got a calculator. Total inventory would be, you'd add up the value of the suits with trousers, underwear, sweaters, ties, and socks, and shirts. I didn't underline that one. I didn't see it. That could happen. I could see you, maybe missing that one. I just missed it when I was doing this. I'm adding up 1, 2, 3, 4, 5, 6, 7 different numbers. And the total inventory added up to 168,000, whatever, adding up those 1, 2, 3, 4, 6, 7 numbers. I have a problem here on scatter plot, but you won't see one on the exam. The idea of a scatter plot, I'll just go over it in case you had a question on it. You will not repeat see one on the exam. Scatter plot is like back in the day when you had an XY axis and you were plotting ordered pairs. Now, the reason is the first ordered pair I see here is my X value is -5 and my Y value is 3. And what I showed you over here is there's that point, -5. You go 5 to your left and you go 3 up. No other graph had that very first ordered pair. -5, go 5 to your left and 3 up. On the x-axis, if it's positive, you go to your right. If the y value is positive, you go up. Second quadrant, you go to your left and then up. And then third quadrant, you go to your left and down. All right, it gets back to the old days when you had geometry. In fact, if you took not college algebra, if you took intermediate algebra, you had a section on plotting points on a Cartesian coordinate system. Once again, I just did that because to show you, in case you're having a problem. Repeat, I will not ask you one on the exam, all right? It's just a matter of, it's XY, it's a Cartesian coordinate system, you're plotting points. So it doesn't get quite easier than that. But here again, you got to get the ones right because they're not going to be all gimmies like this. You know, statistically wise, and I keep saying that word because I've done this course so many times. Statistically, people do better on the first exam than they do on the second because the material gets more challenging. All right. Hope that helps. And let me share my screen. I'm moving on. So last week we went through 1-1 and 1-2. I just went through 2-1, 2-2, and 2-3. Well, the next thing up is chapter 3. And hopefully you're seeing my screen. Hello, I guess you are. All right, everybody.
Yes, we are.
Thank you. Who was that?
Me. Brianna.
Who?
Brianna.
Brianna, give yourself 5 points, okay? She says, how am I going to do that? I'm just joking with you, Brianna. Don't take me too serious. All
No,
right.
you're fine.
Find the mean. We talked about measures of central tendency. You have the mean, median, and the mode. All right. They all have their good points and they all have their shady points. The mean, you've been finding averages since you've been in about the 5th grade. Now, the average is pretty nice way of looking at a set of data and kind of summarizing, hey, what's the average of all these numbers? All right. But the problem with the mean is they can be affected by very high values or very low values. Here's a, for instance, we're in class and I ask everybody, hey, what do you make? What's your average salary? Let's say you're working part-time. People saying, oh, I make 15,000, 20,000, whatever. And pretty much that's the range. You know, people making, you're working part-time. Maybe you're working full-time if it's a night class. Maybe you're making 40,000. All right. Tom Brady walks into the room. Well, Tom Brady's making millions of dollars. We take his salary, we add it with all ours, and we divide by how many people. Well, guess what? The mean is going to be really skewed because of that very high number. A very high number in a set of values or a very low number are called outliers. So that's the bad part about the mean. It can be very much swayed by very big or very small numbers. And then you have the median. Well, the median is the middle number. It's probably a little better than the mean. And if you look at if you ever thought about buying a house, which you will at some point in time, hopefully, realtors will tell you, oh, you want to move to a certain city. The median price in this neighborhood is, let's say, 250,000. That means there is as many houses above 250,000 as there are houses that are priced below 250,000. The median, it's the middle number, different than the mean, not an average. It's the middle number. And the last one is the mode. The mode is used a lot of times. I know back in the day, when I was in college, I worked at a clothing store, all right, a men's clothing store. Now, obviously, in any store, you're going to stock the things that sell the most. And one of the most popular sizes in men's slacks was a 34 waist and a 30 length. So we stocked more 34 30s as we didn't have as many 48 waist and 36 length because we very rarely had a person that had a 48 waist. The mode would tell me what size sold the most. If I was working in the shoe store, I'm not going to stock a lot of shoes size 19, but I'll probably stock for men's shoes. I'll probably stock a lot 9s and 10s, 10s and a half and 11s. Why? There's more of a call for that. Mean, median, and mode. Measures of central tendency. All right. So I'm asking you for the mean of these numbers. Well, ladies and gentlemen, I could just simply add them up on a calculator. There are what, 7 numbers here. Take the sum and divide. I could do that like I did it back on pencil and paper. What I'm saying, if you don't trust yourself to add those numbers and divide by 7, put those numbers into a list. I use it list 1. I went to stat, I arrowed over to calculate. I told my calculator my values were in list 1. I hit calculate, and the very first number it gave me was X bar. X bar is the mean. But that doesn't mean that you had to do that. You could have added those numbers on your calculator, got the sum, divided that by 7, or you could have done it pencil and paper. All right. There's not only one way of attacking anything. All right. Some people like to put it into a list, and some people just do it pencil and paper. Whatever it is, it's just the average. Some more. No, maybe I wouldn't add these myself. Maybe I would put these into my calculator. All right. And then look for X bar. In this case here, X bar worked out to be, the mean was 58.3. Or I could have maybe put these numbers individually on my calculator. There are what, 3, 6, 9 numbers, and then taking the sum and divide it by 9. I mean, how many years have you been finding the average? I give you another one. Doesn't mean you're going to see 3 examples on mean. You probably only see 1. These numbers are fairly large, so maybe I would feel more comfortable putting them into a list and go to stat calculate and look for the X bar. In this case here, X bar would have been 464.2. Now, I hear this a lot, people will do this and, I'm not getting the right answer. Well, let's think about it. How could you not get the right answer? Your calculator does not make mistakes. The calculator only does what you tell it to do. It's a machine. Invariably, if you're not getting 464.2, right? This is, now here again, I talked about this last week. Please set your mode to 2 or 3 decimal places. Don't have 9 decimal places. But the good thing around here, there's nothing even close to 464. So getting back, you do it and you don't get 464. Invariably, you put in the wrong number in your list. Instead of maybe putting in 344, you put in 346. Invariably, you put in something wrong. You tell me, oh, the calculator didn't give me the right answer. Well, it didn't give you the right answer, ladies and gentlemen, because you didn't give it the right numbers. It'll only do what you tell it to do. It's a machine. It doesn't have a brain of its own. It only does what you tell it to do. So please. Number 4, I'm looking for the median. Well, here's a case. The numbers were in natural order from lowest to highest. The median is the middle number, provided that the numbers are in order. Well, guess what? These numbers were nicely set up. Oh, shucks, there are 7 numbers. There's 1 middle number, the 4th one. There are 3 numbers smaller than 59 and 3 numbers bigger than 59. My median is, guess what? 59. Now, what if you had, let's say it wasn't 7 numbers, it was a bunch of numbers. Let's say it was 48 numbers, and you put them into a list, and you went to stat count, 1 variable stat calculate. There it is right there. The calculator will actually do it for you. If you didn't feel comfortable figuring out that 59 was the middle one, the calculator would have told you that it was 59. I'm sorry. If you didn't, yeah, I'm saying, if you didn't feel comfortable with 59, the calculator would have done it for you. Quartile 1, there's the median, which is called quartile 2. But hey, these are already, we're already in order. Pick the middle one. As opposed to number 5, where these numbers are not in order. I've had somebody tell me this. Oh, the median, the middle number is 152. I go, why? Oh, it's the one in the middle. Yeah, but the numbers are not in order. They're not sequential. So what I did is I ordered these numbers. How hard was that? There was only 7 of them. I put them in the order from smallest to largest. Oh, shucks, there it is. There's my middle number. I had 7 numbers. The 4th one is the middle. 3 smaller than 214, 3 bigger than 214. Letter B, 214. Now, here's a case where probably I wouldn't have done what I did here. I just wanted to show you. You've got what, 4, 8, 12, 16. There's 20 numbers. Here's a case where maybe instead of putting them all in order, take me some time, I would probably be better off putting this into my calculator and then looking for where it says, once I went to stat calculate, 1 variable stat calculate, would have given to me. I actually took the time to put these numbers in order. Now, what happened was there was an even amount of numbers, 4, 8, 12, 16, there were 20. So there were 2 middle ones, the 10th and the 11th. When there's an even amount, you have to take the 2 middle numbers, in this case here, the 10th and the 11th, and you average them out. Well, 26 plus 26 divided by 2, guess what it is? 26. I wouldn't maybe recommend doing that because there's so many numbers. You may be better off just putting them into your calc, but the option is yours. There's not one definitive way of getting to the right answer. Oh gosh, give me a break. Find the mode. Which number is used most often? I see a 43 here, and I see a 43 there, and I see a negative 43, a negative 43, and I see negative 43 3 times. It's used more often than any other number. That's my mode. In this case here, this set was bimodal. There were two numbers that were used. 92 was used twice, and 56 was used twice. The set was bimodal. There were two numbers used most frequently. In this case here, 66, I see 166 there. There's a second one there, 366s. 66 was used more than anything else. And here's a case number 10. He's saying, hey, these are retirement ages. What's the mode? Well, each of these values, each of these ages is just used once. It's only 153, 165, 160, 153, 163. Each number is used only once. So there is no mode. There is no number that was used more than any other number. No mode. So we could have a mode. You could be bimodal. I guess you could be trimodal too. Or you could have no mode. All right, brings me to this frequency distribution. I have to have a sip of my Kool-Aid here. This problem drives me right up a wall. Number of people that get this one wrong. And even in my videos, you probably caught that I get a little upset by the tone of my voice. All right. You've got numbers in this list here. You have a second list. Whenever you're asked to find the mean, or in the next section, the standard deviation, whenever you have a distribution, you're going to have two lists. Now, as the videos, I produced a lot of videos, and I even had a couple that I got off the web. When you have a frequency distribution, you're going to have two lists. I suggest putting on one set of values in L1, the frequencies in L2. I told you this way back when. I don't want to use list 3 or list 4. I want to stay with list 1 and 2. That way I know where my numbers are. You have to find the midpoints. In this case, the midpoints of this first set of numbers here. You got 17 employees that made between $5,000 and $1 and 10,000. But you don't know, were there 10 of them that made 9,000? Were there 8 of them? You don't have the raw data. So what you do, you cut your losses. You find the midpoints. So for this very first class here, I take 5,001 and I add 10,000. I add that up and I divide by 2. I get 7,500.5. Now, I do not have to do the same thing for all of these classes, because I realize that my class width, the difference between 10,001 and 5,001, or the difference between 20,001 and 15,001 is 5,000. The class width is 5,000. Once I know this first midpoint, I just keep adding 5,000 to the ones that come after it. Folks, if there was an easier way of doing this, I would have told you. People get this wrong because I don't know what it is. They don't want to take the time to find the midpoints. They think they're going to do it another way. If there was another way, don't you think I would have told you? I'm not going to have you do something that doesn't make any sense. If you have a frequency distribution and they're asking you for the mean, or if they're asking you later on for the standard deviation, and you are not finding the midpoints, you're doing it wrong. You've got to find the midpoints, and people just resist this. I don't know what it is. They just think they're going to come up with, after all these years, they're going to come up with another way of doing it. You're going to come up with another way of doing it, but that another way is going to be wrong. All right, here's another thing. When I entered in my calculator 7,500.5, it took it. All right. When I entered in 12,500.5, well, guess what? There's only enough space here for 5 digits. So what it did, it took this number that I entered in and it rounded it up to 1 higher. You have to trust the calculator. It rounded it up just for display purposes. It knew that you entered in this number, but it rounded it up to the next highest. You have to trust the calculator. It knows what you put in, even though it doesn't agree with what you put. And the reason it doesn't agree, this number here has 7 different places. 1, 2, 3, 4, 5. I'm sorry, 6 places. 1, 2, 3, 4, 5, 6. Well, there's only room for 5 digits here. I mean, this display on the calculator, it's limited. All right. So once I found all my midpoints, I put them in list 1. Here are my frequencies. All right. It's the first time we've seen frequencies. You put those into list 2. Now you may say, why do I have so many decimal places? Well, I've been telling you to set your calculator between 2 and 3 because all my answers have a minimum of 2 places. Here was an unusual. Wasn't unusual. This very, very rarely happens. When I went to the stat, calculate one variable stat, it gave me an answer of 17,125 and 50 cents. The correct answer was this. This answer was incorrect in that the right answer had a 50 cents to it. That will never happen. All right. Put it this way, if it were to happen on the actual exam, I'll make good on it. Here's a case we did everything right and somehow the test had the wrong answer. The correct answer is this, not that, but it still was marked as letter A. If in the unlikely circumstance that were to happen on the exam, because I proofread these, and after I saw this happen a few years ago, I've made sure that I purified my test, that you will never see that. If you've done it correctly, the correct answer will be there. This was an outlier, so to speak. The correct answer does have 50 cents, even though letter A does not show it. All right, same thing here. All right, I've got a frequency there it is, frequency distribution. I want the mean. You better be finding the midpoints. The videos are very precise in telling you that. How do I find the first class midpoint? Take 30. The midpoint is the halfway points, the average. Take the 30 and the 39. It's 69. Divide that in half, 34.5. I see that my class width between 70 and 60 or 59 and 40, the class width is 10. Once I know this first midpoint, all I have to do is add 10 and add 10 and add 10 and add 10. There's no need of me finding the average of the remaining 4. Once I know the first one, just add the class width and I'll have all the remaining 4. Okay, I put my midpoints in L1. My frequencies 4, 19, 50, 15, and 12 go in list 2. All right, and then I'm looking for my mean. The very first thing you'll see is X bar. X bar stands for the mean, 55.70. Now, at this stage, I told you way back when I asked you to get a calculator, I said, hey, ask if you're renting it from the school, to ask the college to give you an 84 rather than an 83. But here's the deal. There are some 84s that actually behave like 83s. If you have an 83 or you figured out that your 84 behaves like an 83, when you go to one variable stat, you've got 2 lists that you need to tell your calculator, hey, my midpoints are in 1 and my midpoints are in, here's the 84 right here. I say, hey, my midpoints are in L1. My frequencies, this number here, this column here, is in L2. I hit calculate, and there's my X bar 55.7, my mean. However, if you have an 83 or an 84 that behaves like an 83, when you go to stat, you arrow over to calculate one variable stat, here's what you're presented with. The calculator goes, hey, one variable stat, and then it just looks at you, it flashes. You have to manually tell it where your values are. In this case here, my midpoints were in L1, but here's the key thing. My frequencies are in L2. I have to separate those 2 with a comma. You'll never have 3 lists. The most you'll ever have is 2 lists, and that would be when you have a frequency distribution. You have to tell it where the values are. L1, comma, you find that on your calculator, comma key, L2. And the same thing pops up. X bar is 55.7. So I haven't received any questions about people with 83s, but I did have one young lady who said Mr. Gomes, you're right. I do have an 84. I rented it from the library, but it behaves like an 83. And the reason it does that, it's got an old operating system. The library has never updated that 84 calculator. You can't expect them to do that. I'm not even sure they actually even know that some of these 84s behave like 83s. Maybe somebody should tell them, maybe it should be me, but they do enough, so. All right, once again, I can't stress enough, and how people get this wrong is, only thing I can just say, they're just lazy. I am not gonna find the midpoints. Okay, then you're getting it wrong. Simple as that. All right, so I added halfway between 70 and 71 is 70.5. I see that the class width here is 2. All right, so I took this, I added 2 and then 2 more and 2 more and 2 more and 2 more and 2 more. I put these into L1. I put my frequencies. It even tells me it's even headed. The column is even headed frequencies. I put my frequencies in L2. I hit stat, go over to calculate one variable stat, and there's my mean X bar 76.7, spot on, spot on. All right, I have a kick. I get a kick out of this. I'll ask people when we're in a face-to-face setting. How many professors actually weight your average? And a lot of hands will go up. I said, do you know how they weighted it? And it goes quiet. No one actually knows how the professor actually weighted it. They can't figure out a weighted average. So my next question is, well, how do you know that the professor did it right if you can't calculate it on your own? I don't know. All right. Here it is. A weighted average is the sum of all your scores times their weights divided by the sum of their weights. Now, I'll tell you, the sum of the weights for our purposes will always be 1. It doesn't have to be that, but in our case, the sum of all the weights, in this case here, if you look at these denominators, 0.20 added with 0.20, 0.20, it's 1. You add 0.40 with 0.30 is 0.7, 0.2 more, 0.9, 0.1 more, 1. Your denominators will always be 1. Well, how do you find the numerators? It's the summation. Summation means you're going to add the scores times their weights. Well, in this first problem here, he tells us that the student had these grades on tests, a 92. No, I take that back. Right here. She had a quizzes. Elaine had a 71, a 75, and a 64 on her quiz grade. She got a 60 on her final exam. She says, find a weighted mean if the quizzes count for 20%. So I took her 3 quiz grades. 71 times a weight of 0.20, added with her second quiz was a 75 times 0.20. Her third quiz was a 64 times 0.20. And I'm adding these up with the score on her final exam. She got a 60 on her final exam and the weight was 40%. Well, 40% as a decimal is 0.40 times 60 in my calculator. Now I did this and I surrounded these values with parentheses. You do not have to put the parentheses in. In other words, your calculator is smart enough to know order of operations. All right. And when you put this into the calculator, whether you're using parentheses or not, the answer would have come out to be 66. It's the summation, which means you're adding of the scores times their weights. Each of the quizzes was worth 20% and the final was worth 40%. And guess what? The sum of the weights, I'm telling you specifically, your sum of the weights, your denominators, when you see one of these problems, will always be 1. Now, people have a problem sometimes with number 15, and reason being is how it's worded. It says here the 4 regular tests count for 40%. That does not mean that each one of the 4 tests was worth 40%. It's 40% total. If you have 4 tests and they're weighted 40%, means that each one of your, in this case, quizzes, not tests, was worth 10%. You got 4 of them. Not each one is worth 40. Each one is worth 1/4 of 40, 10%. You have 4 of them, 40%. Each one was worth 10%. 10 plus 10 plus 10 plus 10 is 40. So what I did here, rather than, I'm just making use of the distributive property. Here's the case, if I'm making use of the distributive property, I would have to enclose these quiz grades in a parenthesis. I'm telling the calculator to take 0.10 and multiply it times everything that's in parentheses. If you recall from algebra, this is called the distributive property. He tells me in the problem the final was worth 30%, and my projects were worth 10%, and my homework was worth 20%. And those are the grades. All right. So reading this particular problem took a little bit of time. But instead of going, I could have gone 0.10 times 92 plus 0.10 times 79, but I saved myself a little time and a little effort. I put the 4 quiz grades in, or test grades into a parenthesis, and I'm telling the calculator to multiply everything in the parenthesis by 0.10, making use of the distributive property. So if you got that one wrong, is you were giving each quiz a weight of 40%. No, it's 4 quizzes or 4 tests. I forget how it's worded here. Each one is worth 10%. The 4 regular tests count for 40%. Well, no, each one counts for 10%. It was the total was 40%. And that was that. And that was that. So where does that bring us? Where does that bring us? How are we doing on time? 8:06, not bad. Not bad. You should all be seeing 3-2 and 3-3. Yes, so just someone tell me yes. I have to make sure. Someone tell me yes.
Yes.
I'm really happy that someone told me that I had been stopped recording. That would have been catastrophic if I hadn't done that. All right. Let me stop. I just want to see something for a second. I still am recording. Thank God. I want to make sure that would be catastrophic. Okay. Find the range. I'm almost embarrassed to get this on the test, which I don't give you this one. It's part of the curriculum, so I gave you a practice question, but no, I'm not going to ask you for the range. The range is the largest value minus the smallest value. As I scanned this, the biggest number is 59, the smallest number is 11, the range is 48. Okay. Number 2, biggest number was 1435, smallest was 5 1/4. Difference was 9 10. All right, so we talked about mean, median, and mode. They all have their pluses and their minuses. But one of the most important things to summarize data is what's called the standard deviation. You know, you walk into Jordan's Furniture, you're looking for a new living room set, and you ask the guy, usually you'll say to him, you know, what's the average price? And he'll say, well, the average price is around, let's say, $1,100. But many times, especially in statistics, you need to know something called the standard deviation. Now, standard deviation talks about the spread of data. You know, I got a mean, I got an average, but how close are all the values to that average? The average may be 325. You know, I look at the example that I did in the PowerPoint, where I had 3 different stores with prices of watches, and the watches all had the same mean. I think it was $325, but the standard deviation varied drastically, because in some places, the prices of the watches were way away from the middle numbers. There was a huge spread. So sometimes in statistics and mathematics, people need to know the standard deviation. Yeah, I know the middle number, the average, but how close are all the numbers to the average? Are they very close, or there's a wide spread? You know what I do many times when I give the results, I let you know the results of the exam. I will give you the standard deviation. Let's say, you know, after the test on Tuesday, I say, all right, the mean, I'll give you the mean and the median. The mean was, let's say, 82. And the standard deviation was, let's say I tell you it was 5. Well, 5 is a small standard deviation, which means that a lot of the scores of all the people in the class were very close to 82. There were there were a lot of scores that are above 82 and a lot of scores below 82, but they were pretty close to 82, like 78, 85, and so forth. If you see a large standard deviation, means there are some extremely low scores and also some extremely high scores away from the mean. Sorry, the standard deviation talks about the spread of data around the middle number. Now, before we can calculate, if you're doing this pencil and paper, before you can calculate the standard deviation, you calculate the variance. If you remember from the PowerPoints, there were some weird formulas. The idea is, if you're asked for the variance, there is no calculator value that gives you the variance. What the calculator will tell you is the standard deviation. And what you need to do, once you know the standard deviation, you need to take that number and square it. So what I did here is I took these 5 numbers, I put them into my calculator. I went to stat, one variable stat, calculate, and I located the S of X. All right, this is the standard deviation for a sample. It was 8. I simply took 8 and I multiplied it by itself. I squared it and I got 64. The same thing happened. I put these 5 numbers into my calculator. All right, I found that my standard deviation was 9.39. I took that number and I squared it. And the reason that variance isn't used in real life a lot, it's a square number. You know, it's like square dollars or square feet. You know, what's a square dollar? All right, there are applications where in statistics that variance is used, but I really don't want to get it. It's way beyond the scope of this course. The key thing that you have to remember is when you have a problem that asks you for the variance, the calculator will not flat out give you the variance. It will, however, give you the standard deviation. You need to take that value and square it. Variance. Now, numbers 5, 6, and 7, I'm asking you flat out for the standard deviation. So what do? I put these numbers into a calculator. I put them in list 1. I go back to stat, calculate one variable stat, and there it is, S of X, my standard deviation. And here's what you'll find. These, for the most part, as we move on into chapters 5, 6, and 7, you're going to sometimes find some discrepancies. All right, the calculator sometimes is too precise. But where we are now in chapters 1, 2, and 3, and eventually chapter 4, starting tonight, your answers will be spot on. All right. And notice I got my calculator set to 1 decimal place. I sure as hell don't want to see 9 places over here. 5.2, there it is. Number 6, put these numbers. If you're not getting a number that you see here, what you did is you just put the numbers in wrong. It happens, ladies and gentlemen. You get your calculator in front of you, you think you're entering in 47.3, and meanwhile you're putting in 46.3. If you're not seeing the precise number, especially now for this first exam, you've done something wrong. Don't blame it on the, all of a sudden my calculator didn't want to work right. No, it's not. It doesn't have a brain. It's got an operating system. It does not make mistakes. You made the mistake by putting in the wrong number. It just calculated what you told it. So please, if you're not seeing the answer, go back, look at your numbers in the list, and invariably, you know, you put the wrong number. That's all it is. The calculator does not decide all of a sudden not to work. Oh, my calculator gave me, no. Blame it on the calculator. Yeah, no. You put the wrong number in. Sometimes human beings, we don't want to take responsibility for what we've done, you know, and choices do have consequences. And the same thing, you got 9 scores here, put them into a list. I would say list 1 because that's easy enough. Go to stat, calculate one variable stat. S of X is, that was 13.1. This guy here is 19.8. It'll be spot on, ladies and gentlemen. There won't be any discrepancies. If you're finding a discrepancy, you're getting, let's say, 20.8. You go, I don't see 20.8. The calculator, no. Go back, check your values in the list. Make sure you put them in properly. It's just a calculator exercise. That's all it is to it. All right, here we go. Here we go. My favorite friend, frequency distribution. And once again, these are the same numbers as we had in the previous one. You know, you got to find a midpoint. You're going to put these values into list 1. You're going to put these into list 2. There's no other way you're going to get the right answer. You can't take any shot. There are no shortcuts. If there was a shortcut, I would have told you. If I've said this once, I've said it. You know, I hate to belabor the point, but it just irks me how you can get this one wrong. Does it take some time? Yeah. Yeah, but like finding the mode took a lot of time. Gee, give me a break. Putting some dots over some numbers, that took an hour and a half. There are going to be some problems that are going to take you longer to do. This is why you got some easy, really easy ones and some more difficult ones, because this guy here will probably take you 3 or 4 minutes. Once I find this first midpoint, I realize that the class width is 5,000. The difference between any of these lowers and any one of these uppers is 5,000. Once I do this first one, I kept adding 5,000. And once again, there's only space for 5 digits. So your calculator took this 0.5 and it rounded it up. You go, oh, the calculator didn't do what I wanted to do. No, it only had space for 5 numbers. It on its own rounded up. Believe me, it has in its memory, it's got the correct number that you entered in, 12,500.5, even though it's displaying 12,501. It knows what you told it to do. And once again, these are my values in L1, my frequencies, these employees frequencies are in list 2. I go to my calculator, L1, L2, because I got 2 lists, and my standard deviation was $7,100.05, 0.7. Spot on. You got to do the midpoints, put them in L1, and the frequencies are given to you, put those in L2. And we go to calculate, you put in L1 is where my values are, frequencies are in L2. Please use. Here we go, the last one, hopefully. All right, these are my midpoints. I took 0, I added 3, cut it in half, 1.5. I noticed that my class width was 4. I took 1.5, I kept adding 4 all the way down. I put these numbers, my midpoints in L1. These are my frequencies, L2. I went to stat, calculate, one variable stat, and my thing, L1, and then my frequency, my numbers in L2. If I'm using the 83 or an 84 that behaves like an 83, I have to manually enter L1, comma, L2. It doesn't mean you can't use L3 and L4, but darn it, you have to remember where your numbers are. If you keep them in L1 and L2, it's a no-brainer. If you're using L3 and L5, now you have to go back and where did I put the numbers? No, I just think it's more advantageous to put it in L1 and L2. Back in the day, prior to MCAS, they used to rate scores as percentiles. Percentile meant if I did a test and I scored in the 80th percentile, that means I did better than 80% of the other people who took the test. If I was in the 20th percentile, well, guess what? I only did as good as 20. I only did as better than 20% of people who took the test. If you're taking an exam, you want to have a high percentile. I want to be in like the 95th percentile. I did better, or my score was higher than 95% of everybody else. So first thing it says, hey, find the percentile of the given data value. All right. Well, first thing I need to do as I look at my set of numbers here, first thing I notice when you're asked to do a problem like this, the numbers have to be in order sequentially from smallest to largest. So I took a moment, I took these 7 numbers and I ordered them from smallest to largest, right? If I'm not doing that, I must have marked the problem wrong. This is the procedure. You got to put them in order. Well, guess what? There are not all that many numbers here, all right? There's only 7, all right? The formula says if you want to find a percentile of a given data value, you calculate, hey, how many values were less than your target number? My target number is 55. There were 3 numbers that were smaller than 55 because first thing I did was to order them. And then it says, divide the number of numbers less than your target number divided by the total number of numbers. Well, guess what? There were 7 numbers here. So it's 3 divided by 7. And the formula tells me to take that fraction and multiply it by 100. Well, 3/7 times 100, I came up with 43. Now, I had this set to 0 decimal places, all right? But when you're finding percentile, you follow the rules of rounding off. If this had been 43.2 or 42.4, I still have 43.4, I still would have called it 43. And here's the thing, there's nothing even around 43. Couple of things, you got another little formula here, which I'd have this off to the side somewhere. All right, I actually sent you all the answers. I would have this somewhere as well. You got the sheet actually. Know this little formula. First thing you need to do is put your numbers in order. It says, hey, how many values are less than your target number? Your target number was 55. You take the number of numbers that are less than your target number, you divide it by the total number of numbers, which in this case was 7, multiply it by 100. Here's a case where this is kind of a pain because there's a lot of numbers. I doubt very much I'll give you one with this many numbers. But what I did here is to take these numbers, I took the time to put them in order. He's asking me, he says, hey, what's the percentile for the data value 6? Well, what I noticed that there are 3 6s. I choose, if there's multiple values the same, choose the very first one. How many numbers were less than 6? 1, 2, 3, 4, 5, 6, 7. There were a total of 20 numbers. 7 divided by 20, the formula says to multiply by 100. The answer is 35. Number 12, they don't give me any values, but he flat out tells me, hey, I got 200 observations. There were 138 with values less than 89.2. He did all the work for me. He told me how many numbers were less than my target number, 138. He told me how many values, observations I had, 200. 138 divided by 200 times 100, as the formula says, comes up to be 69. That one there was kind of an easy one because I didn't have to order anything. He just flat out told me how many numbers were less than the number I was interested in, and he told me how many total numbers I had. Quartiles. Quartile 1 is the same as percentile 25, P25. Quartile 2 is the same as the median, all right? The median, which is quartile 2, the median. Quartile 3 is the same as P75. I could show you different ways of finding out the number in the third quartile, which is P75. I think of quartiles as quarters, and I say 3/4, that's 75 cents. P75. I could show you ways of doing it, but here's my suggestion, ladies and gentlemen. Without me showing you a confusing situation, which I shouldn't be confusing, and if we were in class face to face, I would take the time. Just put them into the calculator. Put the numbers that he gives you here, these 3, 6, these 8 numbers, put them into a list, list 1 preferably. You go to stat calculate, guess what one of the things is? Quartiles. Quartile 3, 61, and you're done. Are there other ways of doing it? Yeah, but there's only 7 numbers here. Put them in a list. The calculator will tell you what the quartile 3 is. It'll tell you what quartile 1 is. It'll give you the median. There's no such thing as quartile 4. All right, so these examples where, you know, I gave you a value and I said, hey, what percentile or what quartile was it in? And then we flipped the script. Now I give you the percentile or I give you the quartile, and I want to know what number fits those qualifications. You have a little formula here. It says L. You're saying, well, what the heck does L mean? L stands for location. Location. It will tell me where I'm going to find P16. What's the formula say? It says K over 100. Well, this K value represents the P16. P16 is like 16%. I put the 16 over 100. All right, P16. I put the 16 over 100. You see it here. And I multiply it times n. N means how many numbers do I have? I have 30 newborn babies. 16 over 100 times 30. I come up with 4.8. Here's a sucker move. You see where letter C is 4.8? And people go, oh, I got the right answer, 4.8. No, you don't. The formula you're using is for you to find the location of the number in the 16th percentile. All right, I came up with 4.8. If you went through my PowerPoint, this one says, hey, when you're finding the location, you always round up. Well, 4.8, I would have rounded it up to 5 anyways. But I'm telling you, if this had been, let's say, 4.2 or 4.3 or 4.4, I still would have rounded up to 5. Rounding up means no matter what decimal other than 0, you always round to the highest number. It's not the same thing as rounding off. Rounding off says, hey, if it's 5 or more, you bring it up 1. Rounding up means, hey, no matter what this is other than 0, you round it up. So I took 4.5, sorry, 4.8, and I rounded up to 5. That's the location of the number I'm looking for. It's in the 5th position. 1, 2, 3, 4. Oh, there it is. The number in the 5th position is 6.1. There's my right answer. But do you see the sucker answer here? Because people do this and they forget that they're finding the location. This doesn't give you the answer, it just gives you the location of the answer once you round up. 4.8 rounded up to the next highest number is 5. The number in the 5th position is 6.1. Please don't fall for the obvious and pick that, because you go, how did I get that one wrong? Because L stands for location. Here I'm looking for the 85th percentile. All right, so I put 85 over 100, like the little format tells me. The K stands for the percentile, which is like a percentage. You put it over 100. 85th percentile is like the 80, it's like 85%. I'll equate it to that. 85 over 100, there are 40 numbers. Now, here's what happens. This is an unusual one. This is like the flow chart that I presented you. Sometimes you end up, when you do the multiplication, you get a whole number. It happens sometimes. And what the slide, the PowerPoint says, if you get a whole number, all right, the location is the 34th place. If I get a whole number, I need to take the number in the 34th position and add it to the number in the next, the 35th position, and find the average. Means to take these two numbers and average them out. Well, if I take 85 and 89, I average it out, it's 87, halfway in between. That only has to happen when you do your multiplication here, this K over 100 times N, and you come up with a whole number. Now look at the sucker answer here. There it is, 34, because the person's not thinking. They don't have this in front of them. They go, oh, it's 34, there's the right answer. Yeah, wrong. Don't fall for the trap. The L in this formula stands for location. It's not giving you the answer immediately. It's just telling you the location where you're going to find the number in the 85th position. Now, if I'm in the 85th percentile, just think about this. If your professor says, well, your score was in the 85th percentile, that means you did better than 85% of everybody else. You did a high score. Now, how could 34, which is not even listed here, be higher than 34 would be between 30 and 35. You mean to tell me there's 85% numbers less than this? There's only one number less than 30. But look at here. You see where if my number in the 85th percentile is way up here, guess what? All these numbers were lower than your 85th percentile. All right, 85th percentile is a high percentage. It's going to be one of the numbers that are one of the largest ones. It's not going to be some number very small. So many times common sense will deter you from making a crazy. To go along with the frequency distribution, people getting that one wrong, driving me up a wall. I don't know how you do it, just throwing points away is beyond me. This is the other one that drives me up a wall. All right. This 5-number summary, referred to as a box plot. It gives you a 5-number summary is the low number on the bottom here to the left, the high number on the top. It gives you quartile 1, the median, which is quartile 2, and it gives you quartile 3. It's called a 5-number summary. As I scan this, I notice my big number is 8.7. This guy has 8.0. Can't be letter C. All the remaining ones have the right smallest number and the right largest number. I could show you how to find quartile 1 and find quartile 2, the median. I just don't want to confuse it. Here's what I'm telling you. You're given a bunch of numbers and I ask you for a 5-number summary. Folks, take the time, put them into your calculator. Granted, I know there's 30 numbers. Okay, so it's going to take you 2.5 minutes to put those numbers in. All right, but here's the benefit. If you put the numbers in correctly, you go to stat calculate, it's going to tell you, well, guess what? You didn't need to know the smallest number was 5.5. You didn't need to know that the biggest number, the maximum number was 8.7. What you needed to know is quartile 1, quartile 2, the median, and quartile 3. You put these numbers into your calculator correctly, the calculator will tell you all of these numbers here. 6.4, there it is. 7.0, there it is. The quartile 3, 7.7, there it is. It will give it to you. Granted, and all I can think is people get darn lazy. They don't want to take the time to put 30 numbers in. What they want to do is beyond me. I mean, there's other ways of doing it, but invariably they don't know enough to figure out the other ways of doing it. I'm not even going to confuse the situation by telling you. What I will tell you, if you asked to put, in fact, I could actually construct this on my calculator. You don't need to do that. All you need to know are these 5 numbers. The low one and the high one are gimmies. It's the quartile 1, the quartile 2, the median, and the quartile 3. You put the numbers in correctly, the calculator will give you all of the numbers you need. I can't say it any easier than that. I cannot say it any easier than that. There are other ways of doing it. Take the time. You'll only have one problem like this and maybe 40 numbers. Hey, so it takes you 3 minutes, but you're guaranteed you're going to get it right. If you don't take that time and you're doing it on your own, you better make darn sure you know what you're talking about. And I'm not going to confuse anybody right now by going through how you find that stuff out. You know, well, I take that back. You're looking for the median. The median is the middle number. Well, there's 40 numbers here, so there's 2 middle ones, the 20th and the 21st. So I take those 2 numbers, I add them up and divide by 2. So my median is 72. Okay. This guy has a median of 78.7. This guy has a median of 78. All right, these 2 are the ones that have medians of 72. So I already know it's not letter A and letter B. So I'm down to C and D. I could take the time to show you how to do the quartile 1, which is P25, but I don't want to do that. I don't want to confuse you. But I'm telling you, take the time. It takes a few minutes. Put the numbers into a list. It will give you all the numbers you need. It'll give you the 5-number summary. The low, Q1, Q2, the median, Q3. It's a no-brainer. And why people don't do that is, all I can think is they're just darn lazy. You know, I've showed you some tricks on how to, zoom through the really easy ones. There are going to be some, they're going to take you. But if you save 3 minutes on 3 or 4 problems, you got an extra 9 minutes on top of the regular 4 minutes you have. You got 16 minutes to do it. You know, I've seen you young people, most of you are young, younger than me. I've seen you people on your cell phones texting with 2 hands. I can barely text with 1 hand because my fingers are stubby. I'm always punching the wrong key, but I've seen people putting numbers into a calculator is not a big deal for young folks because you're used to having cell phones. Same idea, there's how many numbers here? I forget what, 1, 2, 3, 4, 5, 6, 8, there's 24, 32 numbers. All right, this will take you some time. But once again, you take the time to put these numbers into your calculator, it's going to give you the 5-number summary. And another one, just so you can practice, what are you practicing? You're practicing putting numbers in your calculator. I mean, it doesn't change. It doesn't change. And it'd be nice if you found a couple that, I know my small number is 2.0, my big number is 3.4. Well, guess what? They all have the right low and the right high, right? It's right here. It's the quartile 1, quartile 2 where they vary. All right, but the calculator demystifies everything for you. And there are your answers. There are your answers. So rather than entertaining any questions, I just went through each and every one. Yes, no, maybe. Somebody suck up to me. Yes, no, maybe.
So the exam covers chapters 1 through 4.
Yeah, and only it stops at 4.2. You'll see tonight's homework is covering 4.1 and 4.2. Traditionally, it's the most challenging. Okay, this is why I've made the switch from having the Zoom meeting next Wednesday. I moved it to a Monday, and I moved the test that's normally on a Monday. I moved it over to a Tuesday, just so I can take the 2 hours. It's the most, it's not like a find the mean, median, and mode. There's a little more thought to it. You follow me? This is why I moved it, because I need to spend the time going over that and answering questions. Because traditionally what happens is people do great on chapters 1, 2, and 3, and they take a hit on chapter 4. Make sense?
Yes.
Who was I talking to?
Works for me too. I was asking.
All right, Teddy, it makes sense to you why I'm doing that?
What
Yeah.
day is the test?
Tonight, it's at midnight tonight. Who am I talking to?
Katrina,
Katrina, how long have you been on, Katrina?
since we started,
Someone want to tell Katrina when the test is?
I had to get up a few times.
Yeah, okay, Katrina. It's look at the calendar. It's Tuesday. Tuesday from 11 till Wednesday, 11 o'clock, 11 to 11 Tuesday.
Thank you.
I'm not gonna hold you here any longer than I have to. I finished about 25 minutes early. I will shoot an email out to you probably Saturday, reminding you folks that were on and anybody else that wasn't on of the change. All right, hopefully you look at the calendar anyways, but I will remind people of what I'm doing. And it's to your benefit. All right, trust me, it's to your benefit that I'm doing what I'm doing. I want you to do well. You know, I'm not out to hurt anybody, but it's not a giveaway thing. This is why I've done what I've done. And like I said, even on our second exam falls. Oh, let me just do this right now. Give me a second here. Family emergency incident required my attention. Yeah, stuff happens. I get it. I get it. I understand. I get it. Let me share my screen here. Please do yourself a favor. Do look at the calendar every now and then, because I make sure I update it. So you can see on the calendar where my Zoom class, which is normally on a Wednesday, will be on a Monday at 7 o'clock. I realize that that may not fit your schedule, but I record the meeting. You do not have to do the test until the next day. It opens up at 11 o'clock in the morning and it'll stay open to 11 o'clock on Wednesday. You have 24 hours. Doesn't mean you got 24 hours to do the test. You got 2.5 hours. Once you start, let's say you get out of work at 4 o'clock, you have dinner, you sit down with all your, here's what I would suggest. You sit down with all your worksheets. The worksheets are the answers that I sent to you. The only one I was missing was the answers to 1, 1, 1, 2. And I'll show you where that is in a second. Before you start the test, have all your materials, whatever notes that you have, primarily I would say have the answers. They're not just answers. I actually, in most cases, like I just did right now with you, I have screenshots of how I got the answer. Because the problems are going to be very similar. Ain't going to be the same numbers, but the process is going to be the same. Have all that stuff ready, because once you start it, you from that time, whatever time you start, you got 2.5 hours to finish it. You can't start it and go out and go to the mall or something and come back. No, you got to do it in one sitting. Now, let me just show you something here. You go to courses. No, before I do that, let me go back to calendar. Let me look into, I want to go to August. Notice what happens here in August. All right, our last exam is on the 11th. So I'm not going to have I open it up at 11 o'clock on the Wednesday, you'll have to 11 o'clock in the morning on the next day at 24 hours. So I'm not going to do a Zoom on a Wednesday when the test already opened up. No, what I'm going to do is normally scheduled Zoom is on Wednesday. I'm going to have it on a Tuesday. Now here again, that may conflict with your schedule, but at least you'll have the recording. Hopefully I don't make a bozo error and not record it, but I'll make sure that I'm on my game. All right, so if you can't make that for whatever reason, before you start the exam, it'd be a good idea to review the recording of the Zoom meeting that I'll provide for you. Okay, but notice that. So I've made 2 changes. It's the one coming up next week. The Zoom meeting is on a Monday versus being on a Wednesday. The exam was on a Tuesday, which is unusual. And it's to your benefit because I know what happens in chapter 4 and then our last exam. But here again, I'll always be shooting emails, but it's not a bad idea to look at the calendar to see what's going on if there are any changes, but that'll be the only change we have between now and the end of the course. Here's what I want to show you. I sent you out 3 attachments, but what I want to show you is right here. All right, you have, the only one I didn't send you out is this guy right here. Make sure you download it. You have these other ones I sent you as an attachment yesterday. If you don't have that email, they're all located here. It says worksheet solutions for chapter 1 and 3. Now, as someone mentioned, the exam covers not only chapters 1 through 3, it also covers chapter 4, the first 2 sections. So what you need to do is section 4.2 has 2 parts to this. All right. So you're going to have to download this one, this one, this one. These at least 1 problems. These are a killer. These are a killer. This is why I'm doing what I'm doing, having the Zoom on a Monday prior to the test on Tuesday. People have problems with that one. You don't have to download 4.3 right now. You could. 4.3 will not will not be part of the exam. It'll be sections 4.1 and 4.2. It's just that 4.2 has 2 parts to it. This at least 1 is included in section 4.2. So these are the 4 that you need to download. You have this formula card here. You don't need that right now. And I don't know. You know what I am going to do, though? And I take that back. Let me just show you this formula card. No, you don't need that. What you will do, I'll get rid of that. What you will have to do is a lot of we do in probability deals with cards and deals with dice. And I'll make sure that that's part of your PowerPoint. And even when you're going through the PowerPoint, I have the caption, please download this. And the reason I say that, I've learned over the years, not every family plays cards. I've had people from foreign countries where this woman told me, Mr. Gomes, in my country, women aren't allowed to play cards. The reason I show you that is, in fact, if I can pull it up, or now give me a second here. See if I can find what I'm talking about on my computer. I'll make sure I put that into that list of answers. Give me a sec. Because we're gonna find something. When you want to find something, give me a minute here, I'll get it. I'm doing pretty good on time. Okay, let me share this. All right, I'll put this PDF along with all of the answers. I'll put this in chapter 4 solutions. Reason I give you this is I've learned over the years, now everybody is familiar with a deck of cards. First of all, there are 4 suits, clubs, spades, hearts, and diamonds. And many times the questions deal with face cards. In our deck, a standard deck, an ace is not considered to be an ace card. Face cards have a face on them. In some decks you actually see a face on the ace, but not in this. It's a standard deck. Face cards are jack, queens, and kings. So there's 3 face cards in every suit for a total of 12 face cards. And then I show you a pair of dice. All right. Every die has 6 sides, a 1, a 2, a 3, a 4, a 5, and a 6. Really easy. Sometimes you have questions dealing with rolling 2 die. Hey, what's the probability of me rolling a 4? Well, there's multiple ways of getting a 4. I can get a 1 on the first die, a 3 on the second. I can get a 2 and a 2, or I can get a 3 and a 1. What I'm saying here, if I can go up on this a second and get what I want to get, there are 3 ways of me getting a sum of 4 on a die. A 1 and a 3, a 2 and a 2, and a 1 and a 3. A 3 and a 1, a 2 and a 2, or 1 and a 3. There are 36 possible combinations. You're going to find out that probability says the probability is favorable outcomes over total. Well, favorable, there are 3 ways of me rolling a 4. Total is 36. So the probability would be diffraction 3 over 36. But the thing is, I give you these and have these by your side because not everybody is familiar with dice. I can relate back to when I was a kid playing, board games. And well, since the internet, I'm not even sure if families play board games, but I provide you this, and more importantly, equally as important, I give you the different combinations when you of numbers you get. There's only one way of getting a 2, a 1 and a 1. There's only one way of getting a 12 with a pair of dice, a 6 and a 6, all right? Probably of rolling a 2 would be 1 chance in 36. Probability of rolling a 12 would be 1 in 36. I'll make sure that that's part of your, be prepared before you sit down, because I won't see you. Well, no, I will see you next Monday, so I'll be probably repeating the same things because next Monday will be the day before the test. But be prepared, be already thinking what you're gonna have all your stuff ready. Heaven forbid, the clock is ticking and you go, oh, I don't have section 4.1's answers, and you're scrambling to find it on your computer or print it out. Have everything prepared so you can take full advantage of the time, because 2 hours and a half sounds like a long time. And traditionally, people don't take that. I bet people that do it in 35 minutes. Out of, let's say, 25 people, I may have 1 or 2. But that's okay. If it takes you longer, so be it. You have the time. It's just that be prepared, and you just can't get up and walk around and come back and think because it's open for 24 hours that you have 24 hours to do the test. It's not the case. You got 2 hours and 30 minutes. I think for the exam number 2, I think I give you something like 3 hours. I'm saying to myself, 3 hours. I could almost drive to New York in 3 hours. I could drive to Boston and back. Go to Boston, come back. That would be an hour. I could, from my house, 50 miles away, 60 miles. I could drive to Boston, come back, and then drive back to Boston again in 3 hours. But hey, I give you enough time. I give you enough. Time's not going to be the issue. So that being said, I've got 8:46, and I'm going to stop recording. I will share. I think what happens with this, you automatically get a